Hey everybody. Alright, so for this video, let's try an example solving forces with a 3D system this time. So let's say we have this 10-pound disc right in the center of a smooth ramp, so we know the coordinates here. Okay, so we start as usual, free body diagram. But this time it's 3D, right? So we have this little disc, and then there's this cable over here, this cable over here, and then the disc is 10 pounds, so there's some weight, and then it's 3D. There's some normal force, normal to the ramp in 3D, normal force. I'll call this tension in cable AB, tension in cable AC. Okay, so here's our 3D free body diagram. We pick coordinates are kind of chosen for us already, but right, so there's X over here, Y over here, Z over here. Okay, so we would like to write Newton's second law decomposed, but we really need to express each of the four vectors in component form first, right? So let's try that. So vector, this one, the tension, we don't know the magnitude yet, right? This magnitude we don't know. But the direction, the unit vector from A to B, we can definitely solve for it right now. Right, so this is unknown. I'm just going to write the magnitude like this. But the unit vector from A to B, no problem, right? So from A to B, so 0 minus 5, right? And then 6 minus 1, and then 0 minus 4, and then divide by its own magnitude. Okay, so we got the unit vector at least. Okay, now how about from A to C? Same, right? We don't know this magnitude, but the unit vector from A to C, we could definitely solve for it, no problem, right? Unknown magnitude from A to C, right? So 8 minus 5, four minus 1, 0 minus 4. Okay, divide by its own magnitude. Alright, how about this normal? So it's normal to the ramp, so we don't know the magnitude, but the unit vector normal to the ramp, if you kind of take if you look side view, like if this way is Z and this way is Y, right, then the normal force is this way, normal force. But we can decompose, right? If you look here to here is some angle theta, which is the same as this angle theta over here, right? Which is just arctangent of 2 over 8, right? 2 over 8. So we know the angle. So what is the y component of this is, right, this unit vector, I should call it E hat, right? So normal. The y component is adjacent to this angle, and the magnitude is 1, right? So in the x direction, 0. In the y direction, 1 times cosine theta. And in the z direction, it's opposite this angle, so 1 times sine theta, where the angle is arctangent 2 over 8. Okay, and then the weight is a vector it's 10 pounds, and vertically down, right, in the negative j direction. Okay, so we got all 4 vectors expressed. Now we just write Newton's laws decomposed, right? So in the x direction, you take this x component. So that's, let's see, negative 5 over, let's see, 25, 50, 66. TAB, right? So that's the x component of this plus the x component of this. So that's, let's see, 3 over 9, 18, 34. Okay, and then the x component of this, which is 0, and the x component of this, which is 0. Right, so you see how it works now. Then you do the same for y, same for z, right? I'll just try. Y component is this. The y component of this. Y component of this. And then the y component of this. And then same story, right? Z component of that. The y component of, the z component of this. The z component of this. And the z component of this, which is 0. And there we go. Right? That's the strategy. Same strategy, just more math, right? So, and then I'm pointing out the unknowns. 3 equations, 3 unknowns. Okay. All right. I'll see you in the next video.